Today I'm doing a survey of a residence, and as part of that survey we would look at the residence to see if there's wiring errors or outside current flow coming into the residence. Today we have turned on all of the lights in the structure and as many other loads as we possibly can, and then we do a survey in the house with a Gauss meter to determine if there are areas of elevated radiation, magnetic radiation. So I'm using a buzz stick, which is something that can do a quick survey, and we've been able to locate in the floor an area which has high magnetic fields, and subsequent investigation of that has shown it to be a water pipe downstairs. We turned off all of the power for the house by shutting off the main circuit breaker, and we still had the magnetic field on the floor and the current flow coming in on this water pipe that is being seen upstairs as a magnetic field. So that is a condition caused by neutral current from the utility going through parallel paths to get back to the power company. It takes a path through your water pipe, which is metal, and then by various circuitous means back to your service panel and then back out the service wire for your house to the power company. I wanted to show you that although the levels down here at the floor, if we take a look at it with an actual meter, are running 4 to 5 milligauss, but you get back up here on the chair and we're still getting a significant reading in the chair, like 1.2, 1.3 to 2 milligauss. It's fluctuating because that's the nature of power flows that come from the utilities neutral from outside of your house, because it reflects power consumption changes in the neighborhood. Refrigerators start and stop. Washer starts and stops, and that changes the amount of current draw, and that is seen as the amount of current coming into the house goes up and down, and we see that here in fluctuations in the actual milligauss in this chair. It wouldn't be a good place to spend time reading, especially in the afternoon and early evening when power consumption is highest in neighborhoods. People come home, they turn the lights on, they turn the furnace up, they cook, they start doing clothes, and the more we demand in the way of power, the higher this number would go in this chair. I wouldn't be surprised if it went 2 or 3 milligauss during those periods of time. So we will, a little bit later, we're going to move to an area where we've located a wiring error in the circuitry for the outlets in the house, where we are having parallel neutral path, where return neutral is going back 2 ways instead of going back only 1 way, and as you recall, that's a violation of the National Electrical Code, and it causes elevated fields in the house. And we'll take a look at that situation in a little while. I've come down to the basement to investigate the water entrance to the house to see if there's current flow on the water pipe. I brought along my trusty buzz stick to be able to check that really quickly. So we go over here to the water line and give it a check. There's plenty of current and buzzing associated with that. Let's just give it a check now with our clamp-on ammeter to see how much current is on the water pipe. At the present time, we've got like 24 milliamps flow. We've actually took a look at this earlier, and it was up to 500 milliamps, or a half an amp flowing on the water pipe. I'll also point out to you that the current flow follows particular paths because it wants to get back to the utility, and it has to find a path in the house that serves that purpose. So if we turn this back on again and we look, we see that the current's going this way, nothing's going this way. The current goes this way, it goes across the ceiling. We see a T right here. No current flow on the T going off in that direction. All the current flow is going this way into the finished room, family room downstairs here. So we can follow this on the ceiling right across the ceiling. And we start noticing that it's going across the room now. This area is the same area we were looking at upstairs in the living room, where we saw the high magnetic field on the floor and in that chair in the living room. So we'll go right ahead and we'll follow this across the ceiling and see where it goes. So at this point, we've gotten down to the point that we have this soffit built in here, and we're losing track of the pipe because it's so far up. But we know there's a utility room in here. So why don't we take a look in the utility room? I think we'll find something interesting in there. So this is the pipe we've been tracing. Is coming in up off the ceiling and heading for the hot water heater. You'll notice that it does apparently is no current flow below this place where the line for the refrigerator ice maker takes off. And if we test that out, we see that that's going right upstairs to the refrigerator. And it's doing that because the refrigerator is what? It's plugged in, and it has a ground on it. And the water line attaches to the refrigerator and becomes part of the refrigerator metal, and it's grounded. And so this current flow is going up the refrigerator, and then it's going down through the refrigerator power cord, back into the wall, and then down to the circuit breaker panel in the house. All of that is unopposed current flow, and there will be significant magnetic fields around that wire as well as around the pipe, and it'll be affecting various areas of the house depending on where those wires actually run. And with the fluctuation that we get over time with high current flows at night when power consumption in the neighborhood is high, there could be areas in here where the kids are playing after they're home from school during the early evening, where they would be near these areas and subjecting themselves to fields which appear to be as high as maybe 5, maybe even 7 to 8 milligauss, depending on the load situation in the neighborhood. I think now we should go upstairs and see if we can trace this out a little bit further. We've tracked our errant current flow on the plumbing system up into the kitchen following the water supply pipe for the refrigerator. We discovered when we got up here that the refrigerator is encased in cabinetry and would have to be pulled out to be able to trace the flow from the ice maker water connection through the power supply to the refrigerator. And we're not going to do that for fear of scratching up the floors. But we did find that part of the current has come over to the kitchen cabinet and to the garbage disposal and the dishwasher. So you recall my telling you that current flow on the grounding system takes all available paths back to the power company, and it wouldn't just stop with the refrigerator if there was another good path to take back to the power company. And we discovered that with the use of our trusty buzz stick in the kitchen cabinet, both the current flow coming up the water pipe into the kitchen cabinet, and then we noted that it is not going to the garbage disposal, and that's what this line is for, but we did find it going to the dishwasher over here. And it goes to the dishwasher because the dishwasher is connected to the electrical system through its power cord, and that's grounded, and the grounding hooks up to the frame of the dishwasher, which touches the water piping, and so we have a complete circuit, and the current flow can be going through the dishwasher and then back to the power company by way of the ground lead on the dishwasher. We've placed a load on the outlets in the house looking for miswiring or parallel neutral paths, and we seem to have found one. So we're here in the family room with the meter just to show the effect that these sorts of things have on the level of field. So if we come over to the area where people are sitting on the couch watching TV or conversing, and we're noticing we're running a 5 milligauss field, roughly 500% higher than the level we'd like to see people at in the areas where they rest and play. So 5.8 milligauss. We also will see in a second that this is rather pervasive. I mean, this one error, because it's splitting the current flow and it's going on several different neutral return paths, can affect large amounts of the house, depending on where the cables run that those neutral return paths are in. So we have a similar thing in the dining room too. So let us take a look over at that area. So we've arrived in the dining room, and we're looking at a field level of 1.8 milligauss here in the dining room. So not as bad. It's nearly at the level we would consider to be acceptable, but still being affected by this, because when the load is gone, then this is gone. So there's one other area that we've identified being affected by that, and that's the home theater, which is directly under the kitchen area. So we'll go take a look at that. So now we've come down to the home theater, and we're already beginning to pick up elevated fields as we enter the home theater. 1.9, nearly 2 milligauss. As we move into the seating area of the home theater, we're at 2.5 milligausses. 2 milligauss at the seat. It's getting less over toward this side of the home theater, which is obviously moving away from the cables that have that net current on them. We move over this way, and it begins to climb again. And if we choose to sit in this chair here, we're basically at 2 milligauss. The point is that this type of miswiring can have a significant effect on many areas in the house. I remember one situation where a similar thing was what happened, except that the load was a crock pot in the kitchen, which was set on Friday night, and it cooked all Friday night to be ready for dinner on Saturday night. And all of the elevated magnetic fields, which affected the bedrooms, existed throughout the entire night because of that one wiring error. We finished here. It's now time to return to the InterNACHI House of Horrors. So we will consider there some types of wiring, particularly knob and tube wiring, which is what was used early in the wiring of America, and certain forms of Romex that replace knob and tube wiring, and how those affect the magnetic field environment.